Hello, good morning. This is a course of Ansys CFD, and this is the part 1, that is the ICEM CFD. In this course, we will cover the general working of the ICEM CFD, how to create the domain, how to create the geometry, how to import the different geometrical models from the third-party softwares like ProE, Creo-Parametric, SolidWorks, CATIA, and how to make the tetra and prism meshing. Then we will move to the hexagon meshing, and after that we will learn how to output the mesh along with the boundary conditions and the selection of solver for the CFD simulation. This is the presentation layout. In the first section we will cover the general introduction of the ICEM CFD and its working and the graphical user interface. In second lecture, we will cover geometry, how to import it, how to create the different geometrical entities like points, curves and the surfaces. Then the tetra mesh, where we will cover the shell meshing or the surface mesh, and then the volume mesh using the octave and the finale mesh method. In the octave method, we don't need surface mesh, while in the case of the finale mesh we need surface mesh. So then there are two methods. Either we get the shell mesh, either we get surface mesh using the shell meshing methods, or we can use the octave method and we delete the volume mesh, and then we get the surface mesh, and then we can proceed with the finale mesh method. Then we will cover the hexagon mesh and the blocking concept, and then the mesh output, which covers the solver, boundary conditions and mesh output. We will also cover the different quality matrices and how they are related to the better CFD simulation and the convergence. So this is lecture 1, introduction and GA of the ICEM CFD. ICEM CFD is a state-of-the-art meshing software, and it's a different as compared to the Ansys meshing or Gambit or the Gridgen, in a way that this software is this software has the top-down approach, which means you start with one big volume, and then you move towards the small details like the points and the curves. While in the case of the other softwares, you start with lines, then you move to the planes or the surfaces or the faces, and then you move towards the volume. While in the case of the ICEM CFD, it's reversed. So you first start with the volume, and then you move to the surfaces, and then you move to the curves. Although you have the option of using the bottom-up approach, which are mostly softwares give you, but this will slow down your progress and your meshing speed, and also you will not get the most benefits out of the ICEM CFD. So we will try to emphasize on the top-down approach, but in the case when we need the bottom-up approach for some extension of the meshes, like something like that, we will cover also that topic as well in this course. Generally speaking, there are the main 4 types of the files in the ICEM CFD. One is the project file, which is the .prj. This file is nothing but a set of instructions which contains how the project is constructed. For example, which pattern file or geometry file is related to the project, which blocking file is the outline of the hexagon mesh is also related to that geometry, and also the pattern files contains the geometry information as well as the mesh information. And the last one is the unstructured mesh, which is produced from either from the hexagon mesh or directly from using the tetra mesh methods. And then there comes some less important files, but they are there. For example, for the boundary conditions and the solver parameters, we have the dot apc dot attributes or dot art or attribute file, dot par solver parameters, grf, rpl. These are the general replay files used to automate the ICEM CFD. So first I want to shed some light on the general ICEM CFD user interface. For example, on the top of the ICEM CFD window, you have the icon of the ICEM CFD, and then the ICEM CFD version is 15 here, and then a file name which is currently open in this project. After that, below this bar, you have the main utility menu, where you can open the project, you can create a new project, you can save as, or you can import the geometry, you can open geometry, you can close geometry, you can open mesh, close mesh. Similarly, you can close, open, or save the blocking. And second menu is the edit menu, which gives you many options like copy, paste, and undo, redo. And then a view menu, where you can set the different views like top, down, bottom, front. So it gives you the many other different options for displaying the model on the screen. Then the info menu, which gives you the information about the geometry, mesh, and also on the files of the ICEM CFD. And then there comes the general settings of the ICEM CFD working, like you can change the background color, which is currently over here in the graphics window is the white. You can change it to the black. You can change it to the 2 or 3 different colors with the shades. And then the last menu is the help menu, where you can get help about the ICEM CFD. Then there comes the icons. These are the quick access icons. They are derived from the main utility menu. Some functions are not available in the main menu, but most of the functions are duplicated over here. These are used to access the ICEM CFD in an efficient manner. For example, you can undo or redo from the quick access icons instead of going to the edit menu, then use these options. Similarly, you can get the wireframe and solid view directly from the quick access menu, quick access icons, and also you can open the project, you can save the project, you can open, close, or save the geometry, you can open, close, or save the mesh, and you can open, close, or save the blocking. After that, we have the function tabs. These are the main. This is the main machine of the ICEM CFD, which is the workhorse of the ICEM CFD. Here you have the option for the geometry, where you can create the different geometrical entities like the points, curves, surfaces. Also, you can create the body. Now here comes what is the body. Okay, so I can define it as a body is something body is related to the volume or solid. So in the general meshing softwares, you are mostly deal with solid. So you have to divide the solid into different small parts and you have to mesh them. But in the case of ICEM CFD, the main working engine behind the ICEM CFD geometry kernel is the surface-based parasolid kernel. So you cannot get the solid over here. Even if the model you are importing is a solid model, but when you import in the ICEM CFD, you will only get surfaces. Okay. Now, how you can define that the in which section of the geometry you need a mesh, that is a volume mesh. So for this case, you will define it with the help of the body are the material point. And second comment that these the point the body material where you are going to define the region that should be close with the help of the surfaces. So there should be no gap between the one closed body surfaces and the other surfaces. And then you define the point. Now ICEM will mark this one as a volume for the mesh. And then there comes the build topology and the repair geometry options. Also there are the options for the transformation of the model, like translate, rotate, mirror, scale up, rotate and mirror options combined in the one command. Before these two options we have the dealing with the faceted geometry. So these geometries are generally they come from the medical images. So whenever you're working with the MRI like something, you can work with the faceted geometry over here. But the better option I would suggest you use the FE modeler. And this comes in the workbench. So you just go there and process your geometry there and then import to the design modeler. It's the better route. In the second option is in the geometry. Also you can delete the geometric entities. You can delete the point only. You can delete the curve only. You can delete the surfaces only. You can delete the body only. The advantage is that whenever you are deleting any entity using these special tools, you are only able to delete the points, but the curves which are in the vicinity or surface in the vicinity of that point will not be selected. So in this case you are safe to only delete the points which are not necessary for that case. Also you have the general tool, and using this tool you can delete any entity, whether this is the point, curve, surface or the body. After that, then there comes the mesh menu, where you can define the mesh parameters, general mesh parameters. You can define the periodicity, you can define the volume mesh parameters, you can define the shell mesh parameters, you can define the mesh sizes on the parts, curves and surfaces. And then comes the also you can in the mesh menu you have the option to compute the mesh using different methods like the Denali and the octree. Then there comes the blocking. Blocking is basically a skeleton of the hexa meshing. So for creating the hexa mesh, before the blocking menu or the tab, we have the mesh menu. This mesh is only related to the tetra plus prism mesh. During the creation of tetra prism mesh, you may also get the pyramid mesh, where the prism mesh is not possible. So in the mesh menu, you are dealing with any other mesh type other than the hexa mesh. While in the blocking, ICEM CFD has combined all the functions related to the hexa mesh inside the blocking. So once you get the blocking for that mesh, as you can see over here, this is a full hexa mesh. You need to convert that mesh to the unstructured mesh. Now that will be transformed to the mesh, something like you get from the mesh menu over here. The only difference is that with the help of the mesh tab, you can only get the tetra and prism mesh, but with the help of the blocking, you get the hexa mesh. And then there comes the edit mesh, where you can edit your existing mesh. You can merge two meshes, you can combine them. Also you can convert the tetra mesh to the hexa mesh, you can change the hexa mesh to the tetra mesh, and also you can refine the mesh in some particular area. You can extend your mesh, you can revolve your mesh, and also you can process the prism meshing. You can increase the number of layers inside the prism mesh. You can also change the distance of the first cell from the wall of the prism mesh. You can also change the ratio of how they grow from one layer to another layer. All you get inside the edit mesh menu. And then the last menu is the output mesh, where you can select this particular solver like Fluent, CFX, CFDS, and many other solvers for the CFD purpose. And also you can set a boundary condition over here, and then you are able to output your mesh to the particular solver. And below that you have the model tree, where you see all the main four entities of the ICEM CFD, which are the geometry, mesh, blocking, and the parts over here. And over here you can see in the geometry we have some global sets of the geometric entities like points, curves, and surfaces, and also bodies over here. Similarly, we have the mesh, which is the result of the conversion of the hexa mesh to the unshare mesh, or directly creation of the tetra mesh from the mesh menu. And then there comes the parts. The parts are basically they are the derived or the subsets of the geometry. So parts can contain the point, curve, or surfaces, or the combination of the point, surface, and curves in the one single part. For single surface, for the two surfaces, you can have the one part or you can have the two different parts. Also, the parts hold the meshing information when you define the body or the material point. So this will be shown in the pass list. So that is related to the mesh, which holds all the mesh inside this geometric model. And you can create the different parts with the help of the part menu. You just right click on this menu and you will get the first option is a create new part. And you can if you uncheck any part, the mesh of that part won't be exported. Also, the parts are very useful to define boundary condition. Otherwise, you are not able to define different surfaces with the help of the different boundary conditions if you don't define the parts. So parts are also necessary to define the boundary conditions for the solver. And then there comes the data entry zone. For each command, you may need to input some data to command to be processed. For example, if you want to create a point, so here we have click on the first on the geometry tab and then the point tab, and here comes the data entry zone for with the different options. For example, here the XYZ menu option is chosen. So for XYZ, that is to define the point with the help of the XYZ coordinates. So in this case, you have to enter the X coordinate, Y coordinate, or the Z coordinate. After that, just click on the apply or OK, and the point will be created inside the graphics window. This all is the graphics window, where you see all the working and all the models over there. After that, we have the message window, where you can see the what is happening inside the this graphics window, and also what commands are outputting and what is happening there. So you can see all things over here. The histogram, where you can check the quality of your mesh, and it's a selection toolbar pop-up. So for the blocking, geometry, and the mesh, different toolbars with a different option will be there, but general layout will be similar. You can see over here we have this is basically a mesh toolbar, which is visible from here. It's the surface mesh, volume mesh, line mesh, and the point mesh. So here you can select the different options. You can select only surface mesh, you can only select the volume mesh. Similarly, for the geometric options, you have the option for the selection of point only, selection of curve only, selection of the surface only. This all will be covered in the next tutorial, which is followed by this lecture. And then there comes the this graphics window, where the geometric model and the mesh will be shown there. Also there is a display right. You can click on any axis and you will get the view normal to the other two axes. For example, if you click on the Z axis, you will get view on the X and Y plane. If you click on the Y, you will get the view in the Z and the X plane. If you click on this sign circular dot, you will get the asymmetric view. So these are five types we have just covered. In the model tree, I have already told you that this model tree will contain the geometry, mesh, blocking, and the parts. Geometry is a global set of the geometrical R entities inside the model, while the parts is the derived form of the geometry. So here I divided the different surfaces into different parts, like surface B, surface C, surface D, surface E, surface EF. But in the typical simulation, you will normally define them as the inlet, outlet, symmetry, wall, pressure inlet, velocity inlet, something like that. And then there comes a mesh, which is the result of the creation of mesh from the mesh menu, or conversion of pre-mesh as a blocking to the mesh. So for conversion for the hexa mesh to the unstructured mesh, you just need to right click on the pre-mesh and then convert. There is the option to convert to the unstructured mesh, and you will get the mesh over here. Also you can get the full hexa mesh for the typical story solvers, like the NASA is still using, or the older versions of the CFX, which were based on the which are based on the structure mesh. So you will also get those options over there also. For in-house some in-house solvers, you also need to have the structure mesh. So just right click on the pre-mesh and you will get the option for the conversion to the structure mesh easily. So it's a blocking, mesh, geometry, and the parts. So you can group these things: geometry and the parts, blocking and the mesh. So geometry is a global set of points, current surfaces. Parts are subset of geometric entities and used for defining boundary conditions. They can contain points, curves, surfaces, or any combination. It also holds a mesh and the pre-mesh. This is some general settings of the ICEM CFD. You just need to go to the main menu, click on the settings, and you will get the large menu of the different options. These are first two options, the general and product. From the product, you can select the which type of the commands are the working or the displayed on the your ICEM CFD GUI. For example, if you are only working with the Ansys solvers for the CFD version, you just need to select this project, just click on it, apply, save the project, and again you open the project and you will get the options only for the Ansys solvers. You don't get the options for the outputting mesh to the FEA. You don't get the options for outputting the mesh to the different other CFD solvers. So in this way you can speed up your meshing process and to output to the solver in very quick fashion. For example, here we have selected the CFD version. Here basically it's not there. This one is a CFD version, Ansys CFD solvers. So you get the many options of the Ansys CFD solvers, like the Fluent, CFX, and other solvers. And in the next slide, you can see what is happening with ICEM CFD layout when you select different settings over there. For default, you have these all options. For FE and CFD utilities, you have also similar options. for CFD version. This is basically a FE version only, and for the Ansys CFD solvers you get these options. And then you can change the display of your ICEM CFD. For example, the background colors, whether you want to display the XYZ axis or not, and percentage view of percentage, how they are going to fit on, number of elements displayed, and the font size, the size of icon size, the normal, large and huge. You can simplify geometry. You can display or disable or enable the overlays. You can enable or disable the points in the geometry menu, in the model tree. So there are many options you can do it. So in the first tutorial we are going to cover the basic working either of the ICEM CFD, its general layout and the GUI, menus, quick access, icons, function tabs, model tree and different types of files in the ICEM CFD, setting a working directory and starting a new project, opening, saving and closing, project geometry, mesh and blocking, importing geometry, mesh and blocking. Thank you.